All right, so today we're going to be going through surface area and volume of prisms and cylinders. And actually, if you look in the book, if you were actually to go to the textbook for 11.5, they're only doing volumes of prisms and cylinders, and that's because surface area is covered in other grade levels now. So as we're transitioning to what is called the Common Core, there are different things that sometimes you may have touched on earlier on, you might not have, but we're going to add the surface area in here, okay? So if you were to reference the textbook, you'd only see volume in this section. We're going to add the surface area. So you picked up 2 pages on the way in. The first one is the Start by Thinking. So that's this. I want you to work through this problem, as well as, actually, let's just start with that problem. Once you work with that problem, take it about 2 minutes or so, work with a partner, and just talk about it there. You didn't give them that one.
You gave them.
No, I did not. My kids were intrigued. My own kids. I didn't give homework.
Okay, well, the day before, you gave them a bunch. You said you gave them like 4 pages.
They're lying. They're just making you feel bad for them. All right, here we go. So, good point came up. You can't find the volume in terms of like numeric volume, but you could find the volume in terms of coins, right? What is the volume by the cylinder? Well, what is the volume of that in terms of coins? In other words, there are 16 coins. So the volume of A, and we usually write that like that, volume of A is equal to 16 coins. What's the volume of B?
16 coins.
It's also 16 coins. So this is called a right cylinder. This is called an oblique cylinder. Okay? So we have a right cylinder because it comes down and hits the base or hits the ground to the surface that it's resting on at a right angle, whereas this one doesn't. The actual height of this figure, this would be like if it was a building made of coins. That'd be kind of cool building. Okay? But there's like someone hanging off the end here dropping a tape measure to the base. Okay? So it would fall down and hit right here. All right? It's 16 coins. However, did the volume change? No. Okay, the stacked coins didn't change. The volume didn't change. So what conclusion can we make about a right and an oblique cylinder? Yeah. Yeah, they're going to have the same volume. All right? It's not going to change. Okay. Now, let's talk about some of these formulas that we're going to go through here in a minute. But any questions on that? That's just kind of an intro to some of the stuff we're going to do today. Most of the things we cover here are going to be dealing with right prisms, but you may see those oblique ones, and remember the volume doesn't change. Okay, you get the same figure there. So on 11.5 here, I have 3 different pieces here. It says find the surface area and volume of each solid. Now I also gave you another sheet that you're going to hopefully add to your notebook. And this is one that I use in our other book when we're doing chapter 6. In fact, chapter 6 is a good one if you're referencing to go back and look at formulas if you need them. But this is going to be your formula page. So you'll note throughout this chapter, we're going to have 3, 6, 9, 12, 15 formulas. Now, your goal is to be able to relate these formulas to one another where appropriate so that it's easier for you to remember them. All right? For instance, prisms and cylinders, their formulas relate. There's a way to relate them. So it'll make it a little easier. So that would put these two together. That means 6 of those formulas kind of, you can kind of tie some of that stuff together to kind of chunk it into your memory bank. That'll be what we do today. Okay? So have this next to you and be able to add some formulas. Finding surface area. Well, why don't we figure out what surface area means? Go ahead and tell your neighbor what surface area and what you think volume means. Okay, what does surface area mean? Chase, what's surface area?
Would it be like when you flatten the shape out, like into all its, all of like the polygons or whatever?
Yeah, so when you fold out a shape, like if you were to take this, if this was like a box, and you were to take it apart and kind of lay it out, we call that a net. It would be the area of all the faces that make up that shape. Okay, so when you add up all these faces, the front face, the top, the bottom, the back here, how many total faces are here? Yeah, a total of 5 faces. When you add up the area of each of those individual faces, that is your surface area. Now I'm going to go through formulas here, and it could make it very complex for you, but remember when you get back down to it, really the surface area just means find the area of each face and add them all up. So if you forget formulas, dude, it's as simple as that. Okay? So right now, I want you to find the surface area of this polygon. Find the surface area of this, and then try to find the surface area number 3. It might be a little more complex. Well, you can try 4 as well. Go ahead and spend about a couple minutes working. Go ahead and get your attention up here. How many were able to find the surface area for 1? What do you think it was? How about 2? 3? Couple? How about 4? Were 3 and 4 the toughest? Most difficult one? You haven't even started on them? Okay, well let's at least talk about 1 and 2, okay? Well, actually, let's... Numbers 1 and 2, what type of shapes are these? They are polyhedrons. What type? They are prisms. This is a triangular, and this one's rectangular. Tell your neighbor why this one's called a triangular prism, this one's called a rectangular prism.
What's that?
Okay, why is this one triangular? Grace? Triangular base. This one has a rectangular base. Both bases are connected by polygons. Okay, by those polygons called rectangles. It's a key piece. In prisms, the bases are connected by rectangles. Now that's, obviously here, but in this one you see the triangles. The 2 triangles are connected by a bunch of rectangular faces. Okay, now let's see if you get the same answer that I get here. So first thing I do when I'm dealing with a triangular prism or a rectangular prism, any prism in general, is I take a look at the base. So if this is my base is a triangle in this case. I just do a quick sketch of that triangle. I know that this is a 6, that's an 8, which using the Pythagorean theorem, that makes this a 10. Everyone agree? 6, 8, 10. A squared plus B squared equals C squared. 6, 8, 10, it's a Pythagorean triple. The perimeter of this base is, what is that perimeter? 24. Good. You add them all up, you get 24. 6 plus 10 plus 8, 24. All right. The area of that base is 1/2 base times height. Base is 8. Height is 6. 8 times 6 is 48 divided by 2, 24. So the area of the triangle is 24. Now, I don't have any units on there or anything. I'm not too worried about that yet. Okay? But are we there? Okay, now, obviously, some of you are like, well, that's not what I did, and that's okay. Just follow along. I'm going to first come up with what's called lateral area. Lateral area, okay, I'm just going to say LA. Lateral area is like the wrapping. It's the out. If this was like a container, and this was the top of my container, and the triangle in the bottom was the bottom of the container, the lateral area is the wrapping of the container. It's the area of all these faces. Okay, now I know most of you probably just said 10 times 7. You said this front one's 70. 8 times 7, which the back one's 56. And then 6 times 7, which this one's 42. How many got those? Okay, so you get those measurements. What I'm going to do is think about what those things have in common. If I think 8 times 7, 10 times 7, and 6 times 7, what do they all have in common? 7. They all have the height in common. Okay, my lateral area really is what's called perimeter, 6, 8, and 10 times the height. If you think of it this way, if you think of this figure and you go, well, to find the area, the lateral area, the wrapping of this, I'm taking 6 times 7 and I'm adding it to 8 times 7, then I'm adding it to 10 times 7. And you're like, well, really, those have a 7 in common? Algebra, we call that factoring. We take that 7 out, and we really have 6 plus 8 plus 10 left. Everyone with me? 6 plus 8 plus 10 is called? Look at this figure. What is that? That's the perimeter of that. So really, if 7 is my height of my polyhedron, my prism, and 6 plus 8 plus 10 is my perimeter, then lateral area is equal to perimeter times height, or height times perimeter. Okay, so lateral area is equal to, we call it perimeter times height. So you may want to define these things. This is your actual formula that if I were you, I would put into this sheet right here. Lateral area is equal to pH. Now, you may want to define what the P stands for and what the H stands for down here. Maybe say P equals perimeter and H equals height. Okay, perimeter and height. You may, maybe even, I'm hoping that you know lateral area is LA, but maybe you put LA right here. Okay. All right. Now, if I'm just finding the wrapping, my perimeter times my height. So in this case, I know my perimeter is 24. That's why I came up with it up here. That's why I write it down first. And my height is 7. 24 times 7 happens to give me a grand whopping total of 168. And I'm going to go ahead and put my measures in this time. That is square centimeters. All right. Okay. Have I found the surface area? No, what do I need? I've got the lateral area. What do I need to finish up the surface area? Need the 2 triangles, which we call our bases. So our surface area, the formula for that is actually lateral area plus what?
2b.
2b, or not to be, but in this case 2b. Okay? 2b. B stands for basis. So once again, if I'm putting in my formula here, LA plus 2b. Now, you may want to define down here, B is the area of the base. All right? And this is your SA here. Okay, so LA is 168. The area of the base we already figured out. Okay, that is 2 times 24. That's why I came up with it there. So I always come up with perimeter and area first of the base. That gives me 168 plus 48, or a grand whopping total of 216 square centimeters. All right, so I found my surface area. How many came up with 216? How many did it the way I did it? Okay. How many used kind of the same numbers? You just did it in kind of different order. Yeah. So what I'm trying to do is I'm trying to make it into a format that you could use for any prism. You can use the same formulas each time. Do you have to do it this way? You don't have to. But I will tell you that lateral area and surface area, area of the base, these are ways that books are going to approach it. They're kind of quick and convenient ways, but if you ever get stuck, you could just default back to what you did to begin with. Okay, so if I'm using that same format here, there's my base. Now, in a rectangular prism, really any of the faces could be a base. What we're going to say is anytime we're looking at a rectangular prism in this class, the rectangle it's sitting on is the base. So in this case, I have a 4 by 10, which gives me a perimeter of 1028, and it gives me an area of 40. So if I'm using my formula, LA equals perimeter times height, same formula because it's still a prism. My perimeter is 28. What's the height of my figure? So I'm finding the wrapping now.
12.
It's 12, right? So 12, well, 28 times 10 is 280. 2 more 28s is 56. So So 280 and 56 is 236, or 336, excuse me. 336, and I have square inches there. Surface area is the same formula. It's LA plus 2B. So 336 plus 2 times 40, or grand total of 336 plus 80, or 416 square inches. Now, how many got 416? How many did it my way? How many did the other way? Okay. Either way works. How many understand this method? Okay, that's kind of the process. Now, any questions on those two? I'm going to try to apply this to number 3. Yeah? We did have to find the volume. I haven't got there yet, though. Okay. Any other questions on those? All right, let's take a look at number 3. How many were able to find number 3? If you found it, tell your neighbor what you got and how you did it real quick. All right. Hey, I'm going to use the same format. Really, this right here, I think it was Emily that asked yesterday, could you, like when we had a pyramid, she said, couldn't that be just a circular pyramid? Was that you? Was that a cone? Yeah, when we had a cone, you said circular pyramid. Well, really, a cylinder is kind of like a circular prism, even though there's no such thing, right? I mean, they have the same properties. You have 2 bases connected by this rectangle. Has anyone ever seen a cylinder that, like if you take your paper for a minute and just make it into a cylinder, right? You just circle it up like that, right? When you take the wrapping of the cylinder off, like on a tin can, what do you end up with? A rectangle. Okay, so you have a rectangle. So really, if I'm finding the lateral area of this, the lateral area is this outer wrapping. It's a rectangle. Okay, and to find the lateral area, we don't really call it perimeter anymore because a circle doesn't have perimeter, or at least called perimeter. What do we call it? Circumference. So rather than perimeter, we can call it circumference. But we still multiply it by the height. Same thing. Okay, so what I'm going to do is I'm going to do the same thing I did over here. I'm going to take those circles. And I'm going to find, I like to list a bunch of measurements here. I like to list the radius, which in this case is going to be 3, because the diameter is 6. So that's 3. Okay, I like to list the circumference. Circumference is CD pi. ET pi, right? CD pi, which is 6 pi. Okay, and then I like to list the area. And the area is pi r squared. No, they're not. Pi are round, dude. Okay? Area is pi r squared, so in this case it's 9 pi. So I quickly have all the measurements that I'll probably use there. All right? So lateral area is circumference, 6 pi, times height, which is 5, or in terms of pi is 30 pi. Now you'll notice I'm not going to change that at all. I'm going to leave it like that because what do I do with the lateral area? All right, I'm starting to lose people. What do I do with the lateral area? Yeah, you add it to your 2 bases to find the surface area, LA plus 2B. So if you're going to ever substitute a value in, never round it. Wait until the very end. So if I'm substituting in, I'm going to use the exact measure, which is 30 pi. 2 times the area of the bases is, well, 9 pi. Good. So if I have 30 pi's and 18 pi's, how many pi's do I have?
48.
I have 48 pi's. I'm counting the same thing so I can combine them. And now I can round it. 48 pi's is? Approximately 150.8. Good job. Okay, and that's square meters. Now, those of you who got it, how many got that? Good. Any questions on it?
Can you round the 30 pi then? To
You
when
could,
you're
except
done?
you could, except for you don't want to round it and plug it in right there. You want to put it the exact value in there.
Okay.
Any questions there? So if I'm going back to this sheet, lateral area really is the same formula, isn't it? It's just we don't call it perimeter, we call it circumference, but it's the same idea. And surface area is the exact same formula. So you may want to define what C equals. C is circumference. You may even make a note to yourself that your lateral area, or excuse me, that your circumference is kind of like the perimeter of the circle. That's how these two things relate. All right. We good?
Yep.
Okay. Last thing we have is number 4, but I'm going to kind of go through that one a little faster. And then we got volume, but we'll talk about that. Okay? Notice this is a cylinder, but it's kind of a half cylinder, right? It's like a can cut in half. So when I'm dealing with lateral area, I still have kind of the same thing, but I want half of it. In fact, I'm going to just show the work that I have for this one. Okay? All right. So you notice here, R is equal to my radius, okay, which is 2. D is my diameter, it's 4. My circumference is usually pi d, right? Or d pi. But in this case, because I only have half of a circle, my circumference is half of that. Okay? Now you'll notice I have plus 4 here. That 4 represent, well, here's the half of the circumference, but then I have this 4 right there. All right, so 2 pi plus 4. And then the area of the circle is pi r squared cut in half, or 4 pi cut in half, which is 2 pi. To find the lateral area, you do the same thing, circumference times height. It's the same formula. So the circumference, 2 pi plus 4, times the height of 15. And we multiply that out, distribute it, 30 pi plus 60. Everyone with me? Okay. Surface area is lateral area plus 2b. We put it all in and we end up with about 166.8. Now, how many got that on that one? Good job, man. Well done. All right. You'll notice in this one, when I go through there, I didn't have to do anything with this rectangular side because it was accounted for by that 4 right there. Okay? All right. Okay, so what I want to do now is I want to talk about volume real quick. Volume, what does volume mean? Volume's the easier one. What's volume? Yeah.
It's like how much space is in a certain configuration or something like that.
Good. It's like how much space is inside. I like to think of it as how much something will hold. Like if you're thinking of liquid, how much liquid could fit in here inside?
Oh, we just found the surface area.
Okay.
We never found the volume.
Yeah. Volume of a prism or volume of a cylinder, they all have the same formula. Volume is equal to base, the area of your base, kind of like the coin problem we had up above. It's the area of the coin times the height of the coins. There's 16 of them. That's our volume. It's the same thing here. It's the area of your base times your height. Okay, volume equals the area of the base times the height. That's all it is. That's our formula. So if you're filling this out, the way these two things relate, well, they're the exact same formula. It's just the base changes. And it can change in any prism or cylinder, right? So this stands for V. So if I'm going through and figuring out the volume here, I already have the area of the base. It's 24. So if I just kind of off to the side here, I could calculate volume. Volume's a quick calculation. Base times height 24 times 7. 7 24s is?
160. Yeah, okay.
Yeah, 168. Kind of weird. It's the same thing as your surface or your lateral area in this one, but volume is cubic. Cubic. Right? You're taking up space, which is cubic. It's a three-dimensional. I want everyone to calculate the volume for 2 and 3. Number 2 and 3. Bless you.
Bless you. So it's 40
All right, 40 times 12, 480. How many got it? Yeah, man. Oh. All right, 480 there. Any questions on it? We already have all the pieces. That's why we calculate these things real quick, right? So volume of this one, in fact, I'm going to do this one right above it. Volume here is the base times the height, or area of the base is 9 pi. The height is 5. So we get 45 pi's cubic meters, which is approximately 141 point. All right, so let's round it. We'll go to the 10th here. All right, kind of ran out of room there. Okay, 141.4 or 45 pi. Volume's a little easier, a little less involved.
Yeah.
Just a little.
Yeah, this is all.
Okay.
This is volume.
Hey, number 4, you go through the same process, right? Here, I put up my amount for 4. Volume is base times height, so we know our base is 2 pi. The area of our base is 2 pi. Okay, and then the height is 15. So 2 pi times 15 is 30 pi, or 94.2. All right, I am past time limit here. Any questions? Why don't you turn your sheet over? Go ahead and take a look at the next page. On the back of that is our assignment for today. Okay, now let me point out that some of these ask for surface area and volume, some just ask for volume. It's a good idea to show your work on a separate sheet. That way you have room. Tomorrow we will be meeting in the Northeast, thank you, the Northeast Computer Lab downstairs. We're going to do SBAC practice tests. Yoo-hoo! I know.